All right, I am going to do some of the problems in your homework that are related to exponential models, just to kind of clarify how exponential functions work. So I'm going to share my screen. And here we are on question 5. It says, find C and A so that f of x equals c a to the x, that's an exponential function, models the situation described. State what the variable x represents in your formula. There are initially 5,500 bacteria, and this sample doubles in size every hour. So the amount of the bacteria depends on the time. As you move forward in time, it's doubling every hour. So that means that the independent variable is time and the dependent variable is the amount of bacteria. In this case, we start with 5,500. So that means your starting value when x is 0, in other words, the time is 0, you're going to have 5,500 and a to the power of 0. So if I plug a 0 in right here in my model, a to the power of 0 is 1. So you just get c by itself. And they're saying that it's initially 5,500. That means when time is 0, that's the initial amount is 5,500. So our c value is going to be 5,500. So and that's when x equals 0. All right, now they want us to find a. Well, if you think about it, when x is 1, it says it doubles every hour. So after an hour, you're going to have 11,000 after an hour. So when a to the power of 1 and your c is 5,500, you're going to have 11,000 equals 5,500 a to the power of 1. When you divide out, let me just go ahead and write that on the board real quick so I can show you, and then I'll stop sharing my screen. So here we have f of x equals c a to the x, and we found c to be 5,500, that's the initial value, a to the x. Now we're trying to find a. Okay, and we are told that this doubles every hour. So when x equals 1 hour, then our function f of x, which is f of 1, is going to be 11,000 because you're doubling it, right? You start with 5,500 and then you're going to double it, you get 11,000. So that means that 11,000 is equal to 5,500 a to the power of 1. But a to the power of 1 is just a. And if we divide both sides by 5,500, we're going to get 11,000 divided by 5,500 is 2. This is 1, and that's just a to the 1 is a. So a equals 2. So now we found 2. I'm sorry, we found a. So going back to our homework, we plug in 2. What does the variable x represent? The variable x is the time in hours. So C is the correct answer. All right, in the next problem, we're again asked to find C and state what the variable x represents. In 2000, the house was worth 220,000 and its value decreases by 11% each year thereafter. So every year you're going to multiply your value by well, if it decreases by 11%, you're going to multiply it by 0.89 because you're taking away 11% from the whole value of the house the previous year. So, initially in 2000, it's 220,000. So let's go back to the board. And I'm going to erase this. Our exponential model is still CA to the X. And initially in 2000, let X equal 0 in 2000. And X is the number of years. So we're going to go ahead and plug in 0, and then we get 220,000 is the value, the value of the house, okay? So f of x, which is y, represents the value of the house. And we are told in 2000, I want to make sure that's right, 220,000. So when x is 0, your y is $220,000, and your model is CA to the power of 0, because when x is 0, that's your exponent, and that just is 1. A to the power of 0 is 1. So C is our $220,000. So we found C, now we have to find A. They're telling us that it decreases by 11%. You're not going to multiply by 11% to find the next year. You're going to take the whole value and it's going to be decreased by 11%. So it's going from 100% down to 89%. So your A is going to be 0.89. And since this is a fraction, it's less than 1 but greater than 0, it's going to decline, all right? And so our model then becomes f of x equals 220,000 times 0.89 to the power of x. And if you graph this in Desmos, let's just do that. So we're going to graph f of x equals 220,000. Oops. Okay. Times 0.89. And then I'm going to raise that to the power of x. And I guess I need to set my parameters here. So let's let the y-axis run from 0, let's say up to 250, or let's say 300,000. As you can see, it's coming into view. And our x, let's just say our x-axis is from, since we're talking about years after 2000, let's just say from 0 to, let's just say 20. And now you can kind of see that instead of exponential growth, we have exponential decline. So the value of this house is really dropping fast. And since we're not going to be looking at years before, we're going to go ahead and restrict the domain. Let's just say that x is greater than or equal to 0. And so this is a model for the value of our house. I wouldn't want to own that house. That value is going down very fast. Okay, so that's enough for those. Those are problems taken from your homework. So have a look at those, and I hope these videos are helping you.